As we continue to work with complex numbers, what we're going to do is we have operations with complex numbers. What does that mean? You know, we're talking adding, subtracting, and multiplying, those kind of things. Operations, mathematical operations. But we want to be able to identify the field properties of complex numbers, which is nothing more than the rules of complex numbers, and perform addition, subtraction, multiplication of complex numbers. As we get into this, you know, we're going to have some words that we're going to need to remember, and you may remember that we have dealt with a conjugate, and what that was in math, it is when the only thing that we have different between a binomial is the sign. So say if we had x plus 4, its conjugate would be x minus 4, the only thing changing being the sign between the two terms. We're going to use that here because it's going to help us get rid of our imaginary numbers. So that would be a complex conjugate is going to be using a complex term. For example, 2 plus 3i. The conjugate to 2 plus 3i would be 2 minus 3i. So again, same principle. Conjugate is the opposite sign, and then of course it's just between two terms. As we begin to work with our mathematical operations, we'll start by adding. And when we are adding, all we are doing is doing the same thing that we've been doing in algebra, is we are going to combine like terms. So what we're going to do is, you know, I can say that we're going to use the association property, right? We're going to group things together because we're going to group our real numbers together, and then we're going to group our imaginary numbers together, and then we're going to combine like terms, and I'm going to have 9 minus 1, and that's going to give me an 8, plus 4i minus 7i, which is going to give me a negative 3i, or it would be 8 minus 3i. So what did I do in essence? I combined like terms. I combined my real numbers, I combined my imaginary numbers. So I'm going to give this next option, give this next problem a go here, but again, I had 9 and negative 1 I combined. I had 4i and negative 7i that I combined. Combining like terms. Let's see here, find the sum of negative 4 plus I and 10 minus I. I'm adding, so again, I would have negative 4 plus I plus 10 minus 5i. So when I combine my like terms, my real numbers are going to be 10 minus 4, which is 6, plus I have I minus 5i, which is going to give me a negative 4i, and then simplifying that or rewriting that to 6 minus 4i, and then that would be my final answer. Okay, so again, adding, we're going to combine like terms. Now when we go subtracting, subtraction, we are going to subtract much like we do any other polynomial. We are going to distribute the negative 1 to where we are always adding. So looking at this example, I have negative 2 plus 6i minus the parentheses of negative 1 minus 2i. So what we want to do, again, is we want to distribute the negative 1, and what that will do is that will change all of our signs in that binomial. So now what we're doing is we are adding. So I get negative 2 plus 6i. Let me back this up a little bit, make sure you understand. Okay, so I have negative 2 plus 6i, and this is negative 1 there, so I'm going to distribute that. I'm going to multiply everything inside my parentheses by negative 1. So negative 1 times negative 1 is going to give me a positive 1, and then negative 1 times negative 2i is going to give me a positive 2i. So now we no longer have to distribute, right? That multiplication process is not there. So now we can combine like terms. And I'm going to have negative 2 plus 1 is going to give me a negative 1. And I'm going to have 6i plus 2i is going to give me 8i. So there you go. We are able to combine like terms after we do multiplication. Okay, now, when dealing with words, sometimes we need to make sure that we reorder it right. So this next example, I am going to subtract this complex number from this complex number. So if I'm going to subtract, right, if I'm going to subtract 4 from, if I'm going to subtract 4 from 7, that means I'm going to take 7 and I'm going to subtract 4 to give me a 3. So when I look at doing this problem, I'm going to have negative 9 minus 8i minus 3 plus 2i, and that's how it has to be set up. And then we're going to multiply everything by negative 1 right here, so we can be adding again. We always want to be adding. So I'm going to have negative 9 minus 8i plus, minus 3, because negative 1 times 3 is minus 3, negative 3. And then negative 1 times 2i, which is going to be negative 2i. Again, simply done. I just reversed my signs. So now I have a whole bunch of stuff I can combine. So I'm going to have negative 9 minus 3 is going to give me negative 12, and then negative 8i minus 2i is going to be negative 10i. So there you go. There's my complex number using subtraction, complex number using addition. So again, same principles, same rules, same that we have been using. Now as we get into multiplying may become a little bit more challenging. Okay, so as we look at multiplication, we want to remember here when multiplying, right? My parentheses mean multiplication. So I am going to multiply. I have negative 12i times 3i, and that is going to be, well, let's see, negative 12 times 3 is going to give me a negative 36, and then I times I is going to give me I squared. And I think we learned that I squared is a certain value, because we did talk about the cyclical properties of I, and we said that I think I was equal to the square root of negative 1, I squared was equal to negative 1, I cubed was equal to negative I, and then I to the fourth was equal to 1. But, hey, let's just go ahead and say that if we didn't remember that, this is going to be negative 36 times I. I is the square root of negative 1, and then it is also times I, which is the square root of negative 1. So we have negative 36 times, again, I'm going through all these steps so you can see. The square root of negative 1 times negative 1, which is, if you think about it, what is negative 1 times negative 1? That is just 1 times the square root of 1. And we know then that that would be negative 36 times 1, which is negative 36. That's a lot of walking through the math here, but if we remember that, hey, guess what? I squared is negative 1, right? Because it's the square root of negative 1 times negative 1, square root of negative 1, so we get negative 1. I could have simply said, and many of you are going to say, well, why didn't you just do that? That's much easier. I could have said negative 36 times negative 1 is going to give me a 36. So there you go. Let's see here. So go ahead and multiply. Again, we're going to multiply. We're going to do the same thing here. In this next one, I have 2i times the parentheses, or the complex number 4 minus 5i. So remember, this parentheses means to multiply, and we have to distribute that or multiply that to everything inside the parentheses. So that would be 2i times 4 plus 2i times negative 5i when I did my distributive property. Now when I multiply my real numbers. So I have 2 times 4 is going to be 8, and 8i. Now I'm looking at a negative because I do have a positive and a negative number. So I'm going to have negative 2 times 5 is going to be negative 10i squared. We did just say that I squared is going to be negative 1, so I have 8i minus 10 times negative 1, and that is going to be 8i plus 10. And when you write your complex number, your real number is always going to come first. So we will go ahead and reverse this, and it will be 10 plus 8i. There you go. This is a okay answer. This is a better answer. 10 plus 8i. And that is multiplying. Now, that was multiplying two monomials. That was multiplying a monomial and a binomial. Now we're going to be talking about multiplying two binomials. And this is where we start to have to use the double distribution, the FOIL method, the box method, whatever method that you use to multiply binomials. So when I multiply and simplify these things, so I am going to rewrite those, and I'm going to have 3 minus 5i minus 2 times negative 2 plus 4i. Now remember, when you are multiplying binomials, whatever method you use, you may use the box method, the double distribution method, the FOIL method, whatever they call it, it's going to mean that you have to multiply this first term times both of these items, and you have to multiply the second term times all of these items. So you're multiplying, in essence, you're going to multiply 4 times. So when I go to rewrite this, I'm going to have 3 times negative 2, and then I'm going to have plus 3 times 4i, right? So that is right here and right here. Then I'm going to multiply negative 5i times negative 2, which is right here, and then I am going to multiply negative 5i times 4i. Now this, when I simplify this, of course, I'm going to end up with just, well, that's negative 6, and I'm going to multiply my real numbers, and I'm going to multiply my i's, imaginary numbers. So here I'm going to have plus 3 times 4 is 12, and we have I, minus a negative 2 times, minus 5 times negative 2 is going to give me a positive 10i, and then negative 5 times 4 is going to give me a negative 20, and I have I times I, so that is going to be I squared. Now, doing some combining like terms, I have a real number here, which nothing to combine it to, so I'll just bring it down. Then I have two terms with just an I in it, and I will go ahead and combine those. So I have 12i plus 10i, and that is going to give me 22i. And then I have this term right here, which is going to be negative 20. And if I want to say that, I squared we know is the value of negative 1. So now I can simplify some more. I have negative 6 plus 22i. Negative 20 times a negative 1 is going to give me a positive 20. And look, I can now do some more addition, combining like terms. I can combine my real numbers. I have 20 minus 6, and that is going to be 14. 14 plus 22i, and that is my my complex answer. So it looks like we were fortunate here. If you notice, I did eliminate I was able to bring it back down to a complex number with just a real number and an imaginary. Looking at that, what we're going to do is conjugates. Okay, so conjugates involve multiplying, but there's going to be something at the end. So let's see here. We have 6 plus 3i times 6 minus 3i. Those are conjugates because they're the same binomial. The only thing different is going to be the sign between them. And when we do this, let's see here. It's going to be 6 times 6, right? Remember, we're going to do the same form of multiplying. We have to multiply one term times everything on the inside, or the other term, and then the second term times everything in the other expression, so when I multiply 6 times 6, I get 6 times 6. Then I'm going to multiply 6 times negative 3i. Then I'm going to multiply a positive 3i times a positive 6. And then I am going to multiply 3i times negative 3i. All right, so when I do that, let's go ahead and do some simplifying. I have 36 minus 18i plus 18i minus 9i squared. Okay, so if you notice, you may not have needed to go this far on this problem or to include this, but right here we had negative 18i, positive 18i, so those two things are going to cancel out. They became 0. That's part of the reason we do the conjugate, is to get rid of that. Now I have 36 minus 9i squared, which is 36 minus 9 times negative 1. Remember, I squared is going to be negative 1. That's going to be 36 plus 9, which is going to be equal to 45. Now, we started by multiplying two complex numbers and ended up with only a real number, and that's what using the conjugate does. It will get rid of the complex number, and the product of two complex numbers, two complex conjugates, is always going to be a real number. So let's see here, this next one. I have, again, I'm going to multiply this entire expression times this entire expression. So I'm going to have negative 3 times negative 3, negative 3 times negative 8i. I'm going to have 8i times negative 3 and 8i times negative 8i. So 3 times 3, negative 3 times negative 3 is going to be a positive 9. Okay, so negative 3 times negative 3 is 9. Now, we know by the rule that these two center terms are going to cancel out. We don't need to multiply those, but you can see that I have a positive 24i and a negative 24i. So those are going to become 0. And then this term right here is going to become minus 64i squared, which is going to be 9 minus 64 times negative 1, which is going to be 9 plus 64, which is 73. Hope I did that right, but again, multiplying by a complex conjugate is going to give you a real number solution in the end. So those operations with complex numbers, we were dealing with conjugates and complex conjugates to eliminate those, and multiplying or operations with these complex numbers are similar to using just real numbers. They follow many of the same properties: commutative, associative, distributive. You have your identities; those are all going to follow along with complex numbers as well as just real numbers. And as long as you remember to combine like terms and multiply, using your cyclical properties of I, everything should move smoothly with these operations.